Okay, so the geometric definition of an ellipse is all the points in a plane such that the sum of the distances to two fixed points, and those fixed points we call foci, or for each is a focus, is a constant. It's always going to be the same length. So we're going to use this definition to derive what the formula, the algebraic formula for an ellipse looks like. So what we're going to start this by doing it where the foci are on the x-axis, and the midpoint between the foci are 0, 0. This is the easiest case of these. We'll get into situations where it's not like this later, but for now we're just going to look at it where we have a midpoint between the foci is 0, 0, and both of them are on the x-axis. We're going to use some variables. The first variable we're going to use is we're going to let this distance, the distance from the center to the focus, or the center, or 0, 0, to the focus is going to be c. And so we're going to have these two values be c. And then the combined distance to a single point, we are going to let that combined distance be 2a. And so when we add those two distances together, so this distance plus that distance, it's going to be 2a. So from there, we can start deriving a formula, and our formula would be the distance from this point, which is 0, negative c. And so x plus c squared, right? X minus a negative c. Oh, my bad. Negative c comma 0, not 0, negative c. Plus y minus 0 squared, or y squared. So that's this distance. And then this distance is just the same thing, except that it's x minus c squared, because this point is c comma 0. And this is y squared. And that's going to equal 2a. And so if we go through and we try to solve this, which basically means get rid of these square roots, what we're going to do is we're going to take one of these two. So we'll take this one, and we're going to subtract it from both sides. And then we're going to square. So we square both sides. So this gives you just x minus c squared plus y squared. This side is going to be 4a squared minus 4a times that square root, because it's like squaring a binomial. And then it's going to be this squared, which is x plus c squared plus y squared. Well, we still have a radical, which we're going to try to get rid of, which means we need to simplify a bunch of stuff. So as we go through here and simplify a bunch of stuff, we get x squared minus 2xc plus c squared plus y squared equals 4a squared minus 4a times this guy. And then this is going to be x squared plus 2xc plus c squared plus y squared. We just multiplied out these. The nice thing here that happens, x squareds cancel, c squareds cancel, y squareds cancel. We can combine these together, and then we're going to try to isolate the radical. So we're going to leave this on the other side. So we're going to subtract 4a squared. So that's going to give me negative 4xc minus 4a squared equals a negative 4a times the square root of x plus c squared plus y squared. Now I want to divide through by negative 4, because I've got a negative 4 in all three of these terms. And so that's going to give me xc plus a squared equals a times the square root of x plus c squared plus y squared. Square both sides again, and so that's going to give me x squared c squared plus 2xca squared plus a to the fourth equals a squared times, and since we squared this side, that square root just goes away. And so that's going to be x squared plus 2xc plus c squared plus y squared when I multiply this out. Distributive property on that right side gives me a squared x squared plus 2a squared xc plus a squared c squared plus a squared y squared. We look to cancel things out if we can, and it turns out we can cancel this out. That's nice. And then if we collect the x's and y's on one side and everything else on the other, we're going to subtract a squared c squared. So that gives me a to the fourth minus a squared c squared on the left. And on the right, we're going to have a squared x squared minus c squared x squared when I subtract this. And then plus a squared y squared. And then that gets us, if I factor out an a squared there, that's going to give me a squared minus c squared. And then here, I'm going to factor out the x squared, so a squared minus c squared, x squared plus a squared y squared. And then what we end up finding out is that when we deal with an ellipse, we actually are always going to set it equal to 1. If you remember when we dealt with a circle, because this is an ellipse, a circle is going to turn out to be a special case of an ellipse. In a circle, our coefficients were the same, and so we set it equal to the radius squared. Well, that's not the case in an ellipse. And so to make things balance out nicely and have some standard look to it, we always set it equal to equal to 1. And so we divide both sides by this a squared times a squared minus c squared. And so you can see in this case, the a squared minus c squared cancels out, and then here the a squared cancels out. So that gives me 1 equals x squared over a squared minus c squared plus y squared, or my bad, over a squared, and then y squared over a squared minus c squared. And so that takes this geometric definition based on a's and c's and gives us a very simple formula, which is 1 equals x squared over a squared plus y squared over a squared minus c squared. But it can actually be made easier if we think about this point being on the y-axis, which basically means right vertically above the center midpoint between those two foci. And the reason for that is that would be right in between. And so this distance would be a, and this distance, if we already know this distance is c, if we let this be b, we would have c squared plus b squared equals a squared. So b squared equals a squared minus c squared. And so it turns out that instead of this, we're going to let that equal this b squared. And so our formula turns out to be x squared equals, 1 equals x squared over a squared plus y squared over b squared. And the a and the b have very specific things. They're defined, and they're going to have two different things that you can think about it. A and b, this is going to be true. C squared plus b squared equals a squared. That's always going to be true. But it's also true that this b is going to be the distance vertically that we go. And then a, because it's 2a, there's going to be a point over here that is going to be a units away from the center. And the reason for that is because we need the distance from here all the way to here to be 2a. And so there's two of these things, and these are the same distance. And so that means that half of that is going to equal your 2a. Those combined is going to equal 2a. So when we draw an ellipse, it's going to look like this. And there's going to always be a point on the x-axis and on the y-axis, and the distance from the center to the x-axis is going to be the a squared, and the distance from the center to the y-axis is going to be the b squared, and then the difference between those is going to be this, noting that one of the a has to be bigger than the b, and in that case, that's going to be where your point is. Is it either going to be on the x-axis or the y-axis, which we'll get into later. And so your general formula for an ellipse looks like this. If This is bigger than we usually think about it in reverse, where we put the b squared over the x squared and the a squared over the y squared.